where we will be, as we did in our summer meeting, the meeting will be done virtually. And I'm delighted to welcome our ETSAP Executive Committee members, Times, modelers, and other interested parties to this webinar. So we have a number of sessions as outlined in the agenda that's available on the website, and we will start with a collaborative collaborative opportunity discussion with one of our fellow technology collaboration programs, the Combustion Technology Collaboration Program. And in essence, one of the things we've been doing within ETSAP in the last number of years is to increase the opportunity for the ETSAP Technology Collaboration Program to find ways, opportunities, explore shared interests with other technology collaboration programs. So the International Energy Agency has nearly 40 technology collaboration programs covering a wide range of areas. And we've had a lot of success in engaging with a number of these, stretching back over the last, probably in a more active way in the last 5 years. So we had a collaboration with the IEA Greenhouse Gas Emissions Technology Collaboration Program, focusing on carbon capture and storage. We have an ongoing collaboration with the Hydrogen Technology Collaboration Program, looking at the role of hydrogen in energy systems models. And we have also had some collaboration with the Bioenergy Technology Collaboration Program. So those are three where we had active projects, but we've also collaborated with a number of other technology collaboration programs at joint webinars and other events. So it's my great pleasure to welcome two colleagues today from the Technology Collaboration Program Combustion, the IEA Technology Collaboration Program Combustion, Martti Larmi and Yuri Kryan, both from Aalto University. And this session will run until 10:45. There's a slight change to the agenda to just 5 minutes shy of what's in the agenda, till 10:45 Central European time. We'll start with two presentations, one from Martti Larmi and a second presentation from Yuri Kryan, and then we'll have some discussion. So I would encourage those who are listening in and in attendance to think, as you listen to the presentations, to think about any questions you might have, but also ideas for possible collaboration opportunities. We do have, of course, as the energy systems evolve to respond to the political goal of increased decarbonization, there's a significant focus on electrification of non-traditional uses of electricity, so in heating and transport. But in most scenario analysis, either on a national basis or on a global basis, we still have a large amount of combustion in our energy systems going forward. So it would be useful to explore where there might be opportunities to collaborate with our colleagues in the Technology Collaboration Program focusing on combustion. So we'll start with Professor Martti Larmi from Aalto University. And Martti is going to talk about the scope and activities of the Combustion Technology Collaboration Program and the the systems analysis task. So Martti, you're very welcome to our ETSAP webinar, and I'll hand over directly to you. Thank you.
Okay, thank you, Brian. And I'm very happy to be over here and tell you about our TCP and also discuss possible collaboration. But I will start now just an overall presentation of our Combustion TCP. And I start sharing my screen. Okay. This presentation is actually made by our former chairman, Jacopo Portero and Karina Alles. We have a system that the chair is rotating so that we change our chairman pretty often. That is something that is not necessarily taking place in all of the TCPs. They are a bit different still. Okay, but our TCP is called officially energy conservation and emissions reduction in combustion, but we call it combustion TCP. We have a pretty long history from 1977 already. And from the beginning, it has been science-oriented pretty much, not giving direct answers, but it has been more like a science-oriented and combustion related to mainly transportation, but also other applications as well, like power generations and also industry. But transportation is from our TCP point of view, the most important. Of course, we have been thinking about IEA strategic objectives and we are looking at those as well. And we will be aligned with these objectives as well. How then we work in practice? We have several areas, several tasks going on, and these tasks go on several years, and we work on task sharing principles so that we are not cost sharing, and everybody is having their own financing of those studies we make together. And our tasks are related to chemistry, and then sprays. Actually, sprays is something that is controlling the combustion pretty much. So that's why it's very important controlling factor how the combustion is really taking place in a very dynamic systems where we are making our main research on. And then of course problems with emission mechanism like soot. Then we have a specific task for furnace type of solid fuel combustion for power plants. Then low temperature combustion, which is actually extreme high efficiency combustion with low emissions. This is something pretty new, perhaps coming in the future. Higher efficiencies and lower emissions, and that's what everybody promotes. Then different tasks for gas engines and also gas turbines. And then we are just starting our task on energy systems as well. We have pretty many countries involved. This is a list of all ongoing international collaboration between the countries and tasks. However, which is very sad, France is leaving our TCP and they will not continue next next year, but they are still, some of the research scientists may still be involved, at least to unofficially. So in this list, an alphabetic order: Finland, Germany, Japan, Korea, Norway, Spain, Sweden, Switzerland, UK, and USA. Then there is written down what kind of things in different tasks are being done. But I think this is maybe some too detailed at the moment, but we can come on this later on during discussion if there is some questions. One more thing that I would like to raise up now about Combustion TCP, besides so that we are task sharing, but we organize every year. Okay, this year it was virtual conference, but like a mini conference, we call it task leaders meeting. And then we physically meet not only the ExCo members, but also the research scientists involved. And this is something, this is pretty nice tradition and helps us to communicate with each other. And we spend typically 4 days together with open-minded ideas and change our research results with each other. Yes, we have an executive committee like all the others, and then we have an operating agent, and this operating agent, this is from Sandia National Lab, and our operating agent is Paul Miles from Sandia, Dr. Paul Miles from Sandia National Laboratories. And then beside Paul, there is a secretary, and with the funds we gather from countries, and then it goes mainly the cost for secretary and some overall things, so that our annual fee is not very big because we are task sharing. Okay. Then I think this is not necessary to go in detail, but we all know that we have to mitigate greenhouse gas phenomena, and emission reduction is something that everybody has to fight for. There are pretty many ways to do, but we have combustion still going on in many places for many years, and that's why this should be, so to say, focused as well. Okay. And of course, our research and development objectives, yeah, they are like this for the future as well. But system analysis has came to our mind to widen our knowledge and also express our interest to the others and join our research results with other tasks. So to make people aware what is the current status and what can be done within combustion. And now this slide is, I think, very important, and we are already interested in IEA bioenergy, And also we have been, well, I'm personally interested in hydrogen pretty much. And it was nice to hear that you're collaborating with bioenergy and hydrogen TCPs already. We have been working on IEA AMF already several years, several times. IEA AMF, so advanced motor fuels, this is more practical oriented, so the giving the present day status, what can be done with the present technology, and what our combustion TCP is looking at more science and what can be done in the future. Also, what is close to us is also this IEA district heating and combined heat and power, also hybrid vehicles, and also energy storage. These are all so that which are to some extent linked to us. And down there, it's ETSUP mentioned. So it's overlapping all these larger areas, and we see that this system analyzing so that is something very important, and also this is a holistic way to look at things, and I believe that at least the politicians should have a holistic way of looking energy at the moment, and energy system analysis in that respect is very important. If we can contribute to somehow your task, it would be very, very nice to do. Okay, these slides were actually made mainly for our 5-year extension of agreement, and there was a little bit too much material, but hope you could be able to point the main facts. Okay, then I will close this these slides and jump into the next ones.
Just while you're doing that, just
Yes.
to say thank you very much, Martti. That was
Yeah.
very useful, I think, for our discussion. And I do see a number of areas. I'll wait till the discussion, but I do see a number of clear areas where there might be opportunities for collaboration. Yeah. Some of the things that jumped out from your slides were, as you indicated yourself, the hydrogen is a shared area of focus. Hydrogen
Yes.
blending with gas is a very interesting one. And also the fuel economy of transport. I noticed you talked about improvements of 20 to 25%. I think this is another area
Yes.
perhaps we can come back to. And solid fuel power plants, particularly, we're seeing a growing use of bioenergy with carbon capture and storage. So it would be interesting to
Exactly.
to explore those three amongst other areas. So thank you very much for that introduction. Is Yuri going to speak next? Is that the idea?
Well, I have some detailed information of our last week meeting on energy systems, and I have some more slides to share with you.
Okay.
But I would like to emphasize now that this H2 is something that we are working hydrogen and hydrogen blending with natural gas. This is something that is going on. Actually, we do make research on that at the moment, but I'm not prepared to show any slides at the moment. But this is something that there's a lot of efforts going on at the moment.
Yep.
And now I have some more things to show with you. Hopefully we have time.
we do have time. My only concern would be at the end we have time for discussion, but I'll leave it in your hands, you know.
Yeah, I'll try to be brief, but this is what is going, well, we had a meeting last week. Do you see this system analysis? Okay, meeting minutes, and I will just have a short presentation what we discussed and who was present over there. Okay, so I'm heading at the moment this system analysis task, and Yuri will tell about our efforts at the moment. But then Professor Hiroshi Kawanabe from Kyoto, he was talking about emissions and also life cycle analysis of vehicle emissions and internal combustion engines compared with electric and hybrid powertrains as well. Then Professor Antonia Garcia from Valencia, he was more focused on vehicle systems, so vehicle systems level, and also well-to-wheel analysis of the fuel consumption, and also LCA was something that interests him pretty much. And then you will hear from Yuri Krojan later on. But then Professor Øyvind Andersson, he's working on these LCA things and comparing electric vehicles greenhouse emissions compared with internal combustion engines with renewable fuels, and he has got pretty interesting results, like this internal combustion engines with renewable fuels can have lower life cycle environmental impact than electric vehicles. He's going to make a publication out of that pretty soon. And also Dr. Peter Jansson, he's working with gas turbines in PSI, and there's a lot of, he told about a lot of activities in PSI related to energy systems, and there are people in this ETSAP. Okay, that was new to me, but yeah, but it is pretty nice that we have contacts from this side as well. Okay, then we had a talk by Aymeric Rousseau from Argonne National Lab, and about their modeling tools, mainly autonomy and grid. They are pretty, so to say, powerful and versatile tools to analyze vehicles and powertrains emissions and life cycle also analysis. Pretty many different powertrain configurations. And just to show to you that we have a pretty extensive list of people who are interested in systems in our TCP. So this is not something that they are contributing to system analysis, but this is a list of people who wants to be informed how this system analyzing this task is going on within our TCP. Okay, that was in brief what I had in mind to show you.
Great, thank you very much. No, that was very interesting. As I say, the things that jump out at me, I've put up in the chat, you know, asking for people to please to write in some suggestions for collaboration from other ETSAP colleagues. But some of the areas I would see, as I mentioned, would be around perhaps the gas hydrogen blending, the fuel economy transport, and
Yes.
the solid fuel and power plants. Another possible area would be, there's a growing interest, of course, at the interface between climate and air pollution. And this has significant implications, certainly in the political discussions around the choices. And I don't know what it's like in Finland, but certainly in Ireland, we have quite a limited discussion, actually. It focuses on energy efficiency, electrification, and renewable electricity. So in many respects, the role of renewable fuels is not fully, it's not a popular discussion point in discussions on kind of climate action, which makes it quite challenging. And so one of the things that we face as energy systems modelers then is when we show results which do show the role of efficiency, the continued role of combustion, but with different fuels and with higher efficiency, so getting lower CO2 emissions but still using combustion, then the question of air pollution always arises. So the and I had seen some analysis showing the HVO, its potential implications not only for reducing CO2 emissions but having a lower air pollution impact than diesel. So I think those are areas that would be very interesting to explore. One of the things, just to before we go to Yuri, that we normally use, so that the language we use in ETSAP is really about its data, and it's data on performance of technologies, it's data on environmental impact of technologies, and it's data on costs of technologies. That's just a very crude representation of how the types of inputs we need to build into our models. But
that is exactly something that we have realized, that we have to transform our research in these kind of numbers.
Yes, yeah.
We have realized that.
And that's where I think collaboration, particularly if it's very exciting to see that you have a systems analysis task that you're already developing. And so I think there's great potential. But let's move on to Yuri.